All right, so now we're moving on to the next section of our 5th unit, but chapter 12 in your book, and that is going to be multiplying and dividing fractions. All right, remember, we're still working on the exact same essential questions. How can we apply the rules of fractions of polynomials? So as you see, or have seen and will see, it's the exact same rules. And why is it important to simplify algebraic fraction expressions? All right, so we're moving on to multiplying and dividing algebraic fractions. Multiplying and dividing algebraic fractions. All right, but let's first, before we go through, let's just refresh our memory when we are multiplying fractions in general. So if I give you 2/3 times 9/4, you can do this one of two ways. You can multiply across and then simplify at the end, or we can simplify beforehand. Since I have a 9 in my numerator and a 3 in my denominator, I know that this 3 goes into 3 once and 3 goes into 9 3 times. So I can simplify beforehand. 2 goes into 2 once and 2 goes into 4 twice. So since I had these same like factors in our numerator and our denominator, we can cancel them out. And now when we multiply fractions, we multiply across. So 1 times 3 gives me 3 and 1 times 2 gives me 2. So this answer would be 3/2. We do the exact same thing when we're multiplying algebraic fractions. You first look to simplify, and then you multiply across. Right? So if you are multiplying algebraic fractions, first things first is we simplify. Then we multiply across. It's the exact same rules as before. And now if we're dividing fractions, 2/5 divided by 6/15. All right, same thing. When we are multiplying, when we're dividing fractions, we keep our first fraction, so it's 2/5. We change the division to multiplication, and then we flip it. We multiply by its reciprocal. So the same thing, it's the first step when we're dividing algebraic fractions. We will keep the first fraction, change it to multiplication, and then multiply by its reciprocal. And then we look to simplify. 2 goes into 2 once, 2 goes into 6 3 times. 5 goes into 15 3 times, and 5 goes into 5 once. And then here we're left with 3 goes into 3 once, and 3 goes into 3 once. So now if we multiply across, it's just 1/1. There's 1 times 1 is 1/1, which is then equal to 1. All right, so it's the exact same steps as if we're dealing with numerical fractions. So let's go ahead and solve. There's 3 questions we're going to go through. All right, so we're asked to multiply these 2 fractions. So the first thing we want to do is simplify. You could actually simplify at the end, but then you're going to be dealing with larger numbers, and it could be a little bit more challenging for you to simplify when it's larger numbers. So in this case, I do suggest that you simplify first. So I see I have a 3 in my numerator and a 9 in my denominator, so I can rewrite that as a 1, and this is a 3 here. I see I have a 10 in my numerator, 2 in my denominator, so 2 goes into 2 once, and 2 goes into 10 5 times. All right, so now we simplified our numbers. So I know that right away, what's left over in my fraction is going to be 5/3. What variables are left over, I'm not sure yet. You can simplify within your same fraction if you want to, and that's perfectly fine. But however, I see a y to the 7th in my denominator and a y to the 7th in my numerator. So I'm just going to completely cancel those out because they are the exact same thing. I have x to the 5th in my numerator here and x to the 5th in my denominator there. So they completely cancel each other out. You did not have to do what I did here. You could have simplified within the fractions and you'd still be fine. But I'm just canceling these out because I see it's the exact same thing. Right now, I have y cubed and y to the 5th. So if I'm taking away 3 from here, that means I'm left with y squared. I have x squared and x cubed. So if I take away x squared from this x cubed, I'm left with 1x in my numerator. So now I'm left with 5x over 3y squared. And that is your final answer. All right, so you completely simplify everything that you can beforehand. And then you multiply what's left over. Well, in this case, all that was left over was this 5 and this x, and this 3 and this y squared, so there really wasn't anything else left for us to do. And that's it for this problem. All right, so now we're asked to multiply these fractions. Now, these ones are probably the ones that you'll see more of, and they are a little bit more challenging, but it's something that you can do for sure. All right, remember, the first thing we look to do is simplify. But when we don't have just the numbers that we had here, where there were just variables that were being multiplied, and here we have either binomials or trinomials that we're looking to simplify, we need to factor. All right, so remember, we look at each one, 10x minus 40, and we factor this completely out. Well, I can take a 10 out, and I'm left with 10x, or x minus 4. So that means this numerator, factors out to 10 times x minus 4. X squared minus 6x plus 8. X squared minus 6x plus 8. We draw our x. It's a multiplication. It's the addition. 1 times 8 gives me 8. The minus 6, this drops here. So since they multiply to be positive and they add up to be negative, I know they're both negative. And factors or numbers that multiply to 8 and add up to 6 are 4 and 2. And then we divide each one by the number in front of the x squared. So it's 4 over 1 and 2 over 1. And remember, this tells us we started from the bottom, now we're here. So then it's x minus 4. Started from the bottom, now the whole class here, x minus 2. All right, so it's x minus 4 times x minus 2. And then we look to factor everything else out. Well, we can't factor anything out of this x plus 3, so that just remains x plus 3. And then the last one, 5x plus 15. Well, we can factor out a 5, so it's x plus 3 over 5 times x plus 3. And then we look to reduce everything that we can. Well, here I have an x minus 4. Let me actually use a different color. Let's just do black. Here we have an x minus 4 and an x minus 4, so they cancel. An x plus 3 and an x plus 3, and they cancel. And here I have a 5 and there's a 10. So 5 goes into 10 twice. So I'm left with just 2 in my numerator, and I'm left with x minus 2 in my denominator. So if we were to multiply and simplify these algebraic fractions out, it would just simplify to 2 over x minus 2. Right? And this is beneficial for us because in the future when we start to graph, it's a lot easier to graph this problem than it is to graph the one that we started with. Or if we were trying to plug in values for x to solve for y, it's a lot easier to use this than it is to use what we started with. All right, there's one more question that we're going to do, and that will be dividing, and that will be it for this video. All right, so now we're going to just go ahead and do one more problem. We're only going to do these 3 because when you're dividing, it's eventually going to be the exact same thing as multiplication. So we're practicing another multiplication problem here because the first thing that we do is we rewrite the first fraction. Then we change this to multiplication, and then we multiply by its reciprocal. So we need to take the second fraction's reciprocal. So essentially, it's always going to come back to multiplication. So even when we're dividing, we're still practicing our multiplication because we keep, change, flip to keep the first fraction, change the multiplication, and then flip our second fraction. We multiply by its reciprocal. All right, so now we need to go ahead, and we're going to factor out each one of these. So x to the 4th minus 9x squared. Well, they both have an x squared in it, so I can factor out the x squared. Now I'm left with x squared minus 9. But this can keep going because we have 2 terms. They both can take the square root, and it's a difference. So this can factor out to x squared times x plus 3 times x minus 3. So we're left with x squared times x plus 3 times x minus 3. All right, then we look to factor out this one here. So then we have x squared minus 4x plus 3. We draw our x. It's multiplication and addition. So 1 times 3 gives me 3. The negative 4 drops here. Numbers that multiply to be positive and add to negative, that means they're both negative. Numbers that multiply to 3 to add to 4, so 3 and 1. And we divide it by the number in front of our x squared. So this factors out to x minus 3 and x minus 1. All right, then we look to go ahead and factor out this x squared minus 16. It's the difference of 2 squares because the square root of x is x. Square root of x squared is x. The square root of 16 is 4, so it factors out to x plus 4 times x minus 4. And then our last one that we factor out will be this x to the 4th plus 2x cubed minus 8x squared. Well, first we can factor out the x squared, so we're left with x squared plus 2x minus 8. Then we go ahead and factor this out, so we draw our x, our multiplication, our addition. 1 times negative 8 is negative 8. The 2 drops. So since they multiply to be negative, one's positive, one's negative. And numbers that multiply to 8 that have a difference of 2 are 4 and 2. And the 4 must be positive since this one's positive, because 4 plus negative 2 is 2. We divide each one by 1, and we get x plus 4 times x minus 2. All right, now we look to see, do we have any like factors that we can cancel out? Well, I have an x plus 4 and an x plus 4. I have an x minus 3 and an x minus 3. I'm sorry, I missed one more. This over here, I forgot our x squared. This x squared was here. So then I go ahead and I can factor out this x squared and this x squared. So all that's left now is this x plus 3 times this x minus 4 over top of x minus 1 times x minus 2. Now, you can leave this as your answer. As of right now, you do not need to multiply this through, and that will be your final answer. All right, so we just did 3 problems that got more challenging as we did it. But if you could do this problem, you could do any problem that we give you. Because every division comes to multiplication, and it's just factoring each one individually. So you're focusing on these one at a time. We're focusing on this first, and then this second, then this one third, and then this one fourth. And then it's easy to just cancel out anything that's common with our numerator and our denominator. So it's really not that hard. It's just a little bit longer. All right, that is it for this video.